In today's video, we're going to be looking at the math methods multiple choice paper 2 text active for 2021. This is for the QCAA syllabus or the Queensland syllabus in Australia. In this video, I'm just going to be going through how to answer pretty much most of these questions here. Now, because it is a tech active exam, obviously there's going to be some things I cannot physically show because it would have to be done by a calculator. And my editing skills are not great enough to show like a calculator on the screen as well. Okay. Forgive me if I pause for some questions because I've actually solved it here in front of me and I'll be checking my working as I go. That way pretty much I can get this all right for you, okay? Now, sitting this exam, you do get access to this formula sheet here. Now, this will be changing in 2025 or 2026, but this is the one you would have used for the 2021, okay? And it's going to be pretty similar information anyway with the new one, okay? With that said and done, let's just get straight into the content. So, question 1. The scores obtained on a test can be assumed to be normally distributed with a mean of 102 and a standard deviation of 9. Okay, so straight away, mu is 102, which is the symbol for the average, and the standard deviation is 19. Okay, what proportions of scores are over 113? So if we imagine this, we've got a normal distribution like this. This average is in the center, 102. Standard deviation pretty much is like just from the center here, so it'd be like 19 on each side. So here, if you would think of, alright, 102 plus 19, that would be like 121, and then 102 minus 19, and that would be 68% of the area here. When it says what proportion of the scores are over 113, what we've got to imagine is with this normal distribution, alright, we've still got the average in the center, but we've pretty much got to think, alright, what side of the curve is that going to be on? So obviously we know it's going to be 113. Now here it's over 113. So we want to know this overall proportion. Okay. Now when you write that like in an exam, you have to write like this. So proportion of our variable x is greater or equal to 113. Now if you're doing a short response, you would obviously use a graphics display calculator. So you just write using graphics display calculator or GDC. Now you actually have to put that physically into your calculator. So if you would put that information in, now your lower bound would have to be 113. Your upper bound, you can choose any large number really. So 1,000 would suffice in this case here. Average 102, standard deviation is 19, lower bound's 113, upper bound got 1,000, and you should get about 0.2813, okay? Which is A here. So that's the correct answer to question 1, okay? Because remember, this is a tech active exam, okay? You wouldn't be able to answer this question by hand, not unless you had like a Z table, okay? If you have any questions about this one here, or any in like this exam at all, timestamp it and tell me like what your question is. That way I can get to it as soon as possible, okay? I'll move on to the next one. So, question 2. A substance is being heated such that its temperature in degrees after t minutes is given by the function t equals 2 e to the 0.5 t. The first integer value of t for which the instantaneous rate of change of temperature is greater than 100 degrees per minute is. Okay, so what we've got to pretty much think here is, alright, what does this word here mean? So instantaneous rate of change. So that means derivative. That's asking when the derivative of this guy here is greater than 100 degrees. So basically when dt, rate of change of temperature with respect to time, is greater than 100 degrees Celsius, okay? So what we have to do is we actually have to physically differentiate this guy here, okay? So if we were to differentiate that guy using chain rule, you get dt is pretty much this number here. So if you differentiate that inside, that will give you 0.5. So it'll be 0.5 times by 2 e to the 0.5 t, which will give you pretty much just dt as e to the 0.5 t. Now, it's asking when it's greater or equal to 100, and they're asking for the first integer. Now, integer value is just like a whole positive number, so like 1, 2, 3, 4. That's why they've only got these guys here in the answers here. So the key to answer this question here is don't work out the inequality, just like set it equal to 100, and just solve for t then. And then you can work out, alright, left or right, when's that going to be greater? Now here, when we're looking at this curve here, obviously as time goes on, the temperature is going to increase because of the exponential curve. So if we know what time it's going to hit 100 degrees, then obviously that's going to be the time when it's going to be greater or equal, etc. Okay, so it's much easier to work at this than the inequality, because that can get a bit confusing. So we'd have to solve for this. So natural log both sides, so natural log of 100. 0.5 is the same as a half, so it's a half t, times both sides by 2, so you have 2 natural log of 100 equals t. Chuck that into your calculator. Now if you chuck that into your calculator, so 2 natural log of 100, or log base e, is approximately 9.21, okay? So when the time is 9.21, the temperature is 100 degrees. Now look at the wording of the question here, okay? The first integer, or the value of t, which the instantaneous rate of change is greater than 100 degrees. Well, if 100 degrees is when the time is 9.21, then when the time was 9, the temperature would have been less than 100 degrees, meaning the next integer would have to be t equals 10. So the correct answer here is A, t equals 10, okay? Because of that wording there, okay? If you have any questions here, leave something in the comments, okay? Alright, question 3. Now, a lot of people struggled with question 3. Now, I would as well, and I actually did at first. But then I took a look at it again, mind you, with the answer sheet as well, and I was like, oh yeah, that makes a bit of sense, okay? So all we have to do is read this carefully, okay? So a random sample of people were surveyed about the most important factor when deciding where to shop, and the results appear in the table. So here we've got price, quality of merchandise, service, shopping environment, okay? And you've got the percentages on that right-hand side, okay? If the sample size was 1,200, the approximate 95% confidence interval for the proportion of people, that's important, who identified price as the most important factor, so price in this case here, we're going to be looking at this guy here, is. Now, proportion is another word for percentage, okay? Now, a lot of people put 40 down. You've got to put 0.4 because 40% means 40 out of 100, okay? So 0.4 is your percentage, which is also your proportion of people who identified price as the important factor. Now, with a confidence interval, if you're not sure what the formula is for it, it's just over here, down here. It's like a bar pretty much, okay? So you're going from your proportion and you're plussing and minusing a particular length on. Now that's your z-score, that's your proportion, and that's your sample size. Now you do actually have to know what it is for 95% confidence interval. So for 95%, Z is about 1.96. You can use 1.95. It shouldn't really matter too much as long as you're about that, but just be careful with it, okay? So you want to be using this formula here, so proportion, plus or minus, and then you've got this guy here, over n, okay? So if you chuck the information in, you're going to basically have 0.4 plus or minus 1.96 times by the square root 0.4. 1 minus 0.4 is 0.6, so 0.6. And the entire population here, or sample size, is 1,200. Okay. Now, if you put the plus is going to give you that upper thing in the confidence interval. So it will give you this value here. The minus is going to give you the lower bound of the confidence interval, because the confidence interval is basically saying between what two values am I 95% confident that this value lies in. Okay, that's all it is. Okay, if you want to imagine a confidence interval, it's like this. Okay, where that's your proportion and that's like your plus z yada yada, and that's your minus z yada yada. Okay, so if you put these numbers in, this is what you're going to get. You should get 0.372 for your lower one and 0.428 for your upper one. Okay. Now here you can see and match the numbers up. So this one matches the lower bound and this one matches the upper bound. So this is the correct answer here. Okay. That's when you put this into your calculator. Okay. So this again is your plus. That's your upper one. And this is your lower one. So if you use the minus, okay, you got to do that twice in your calculator. Okay. All right. Let's go down to the next one. All right. So using trapezium rule. Now I always hated trapezium rule, but it is what it is. With the interval size of 1, the approximate value of the integral, and you've got this guy here. So, with trapezium rule, it's really annoying to remember the formula. Now, in the new formula sheet, it is on there, but we're going to be doing it like with the old one, basically how this would have been done. So, your formula for trapezium rule is B minus A, which is your lower bound minus your upper bound, over 2 times by N, which is pretty much your strips, pretty much. times by f x of 0, which is your first slit, then double all your middle ones, so let's say x of 1, f of x of 2, I'm just going to put dot dot after this, and then your plus f x of n, okay, whatever your last term is, okay. So, in this case here, they're saying use the trapezium rule with an interval size of 1, okay. So, let's think of it like this. We're integrating between 0 to 3. Now, if you have an interval size of 1, all you're going to be doing is pretty much nice whole numbers. You'll be going, alright, 0 to 1, 1 to 2, and 1 to 3. So we have 1, 2, 3 strips. So n is actually equal to 3. That's really important. It's not 1, okay? N is how many strips you have, okay? We have 3 strips because we have that many literally there. If you divide the interval you're integrating into sizes of 1, okay? So here the distance between 0 and 1 is 1. Same here and same here, okay? 2 to 3 is a distance of 1. So that's really important. Now here, my A is 0. That's my lower bound. My B is 3, okay? Now this question does take a bit. Now I hated how they put this on a multiple choice because again, this is only worth 1 mark. It's really not that important overall in terms of the exam, but knowing trapezium rule is quite important, okay? Now, these are your x of 0s and x of 1. So this would be x of 0, x of 1, x of 2, and x of 3. So in this case of this particular exam, I'm just going to use this color. This would be that guy there. And my x of n, I'll just use this color here, is going to be 3, which is there. Now you've got to work at the f of x's of all these. So you've got to work out f, I'll just use a different color. I'll just use this one again. You've got to use f x of 0. So pretty much you've got to plug in that x value into f of x, which is 0.5 to the power of x. Okay, that's the function we're integrating. So this will be pretty much f of 0, which is 0.5 to the power of 0. F x of 1, which in this case is f of 1. So that's 0.5 to the power of 1. F x of 2. I'll probably have to rub some stuff out because otherwise I'm going to run out of room here, which is f of 2. So 0.5 to the power of 2. And f x of 3. So f of 3 equals, let's go 0.5 to the power of 3. Okay. So now we have to plug this stuff into our formula here. So I'm actually going to update this formula here. So that's our generic formula. So in this case here will be 2 times by the middle term, so f of x of 1 plus f of x of 2, and then plus f x of 3. Okay. Now we've literally just got to plug in these values. Now again, this is why it's a calculator exam, okay? So pretty much I'll just use that goes there. I'll get rid of these colors here so it helps a little bit. I like doing these videos in one take. I'm never changing that because I think it's really important. You can see how this would be done raw. This goes in there, and this goes in there, and this goes in there, okay? And of course you've got your A and your B. So now here I'm just going to rewrite those guys there. So here your A is going to be 3. So it's basically 3 minus A, which is 0, and then 2 times by our strips, which is 3. Okay. So I would plug this straight into my calculator. So put those values where they are in the colors. Don't forget the times 2 there. Now when you put that stuff in, it should give you approximately about 1.31. Okay. So the correct answer is going to be C. When you put these guys into their corresponding spots here. Now I won't be able to do it. Don't have enough room. Okay. But you understand what I mean hopefully there. Okay. Right. Let's move on to the next question. So question 5. Solve for x given that log 3 x minus 1 equals 2. Okay, so what we want to do is first of all get it out of a log form, okay? Because we can't break apart x if it's stuck inside a log, okay? So ideally, we've got two main forms that we can switch between. So at the moment we have it like this. Log a of b is equal to q, okay? we can rewrite that and vice versa as a to the q is equal to b. So at the moment we have it currently looking like this. It's more ideal for us to have it written like this so we can get rid of that x. So here I'll write this as log base 3, x minus 1 equals 2. So if I were to rewrite like this would be 3 to the 2 equals x minus 1. Now I don't think you need a calculator for this one here, or you shouldn't do. 3 squared is 9, so you have 9 equals x minus 1, plus 1 on both sides, so x is going to be equal to 10. Okay, so that's how you solve question 5. Oh, actually, I've done that one right. X minus... No, I just made a mistake initially of my working. Yeah, so x is going to be 10. Okay, cool. I was just checking my working. Oh, that's what I did. I put 3 squared equals 8. That is bad of me. Okay. Alright, this one here. Question 6. When seeds of a certain variety of flower are planted, the probability that each seed germinating is 0.8. If 8 seeds are planted, what's the probability of at least 6 seeds will germinate? Okay, so straight away, identify what topic this is. So a seed can germinate or it cannot germinate. We have two options, meaning this is a binomial probability. Okay, so here, binomial probability means we have the probability of something happening, so let's say x, and the probability of something not happening, which is x bar. Okay, so we can split up into two things. Now it doesn't mean equal probability, so in this case here, germinating is 0.8, meaning not germinating is 0.2. Okay, so we have pretty much, alright, we've got, now it's this bit here that's going to be a bit tricky. At least 6 seeds will germinate. So we're looking for the probability that x, where x is pretty much probability of germinate, has to be less than, well, greater or equal to 6. Okay, because basically it's saying at least 6 seeds will germinate, meaning 6 or more. Now, a way we can work that out is pretty much thinking, all right, there's 8 seeds planted. Well, why don't we just work out probability that x is equal to 6 plus the probability that x is equal to 7 plus the probability that x is equal to 8, and just add them all together. Okay, now the probability formula you can use for binomial is, where is it, this guy here. Okay, so here n is your number of trials, so in this case here there's 8 in total. R is your whatever the thing is going to be here, so if it was x equals, let's say 6, R would be 6 in this case here. Okay, P is the probability of the favorable thing. So if it's germs or germinating, probability is 0.8. And then the rest is just filler formula. Okay, so you'd have to do that for each of them. Okay, so here, if you were to chuck these guys into your calculator, so if I were to zoom out, and let's say I was doing this, I'll just write down here, probability that x is equal to 6. Well, that will be pretty much be, let's go 8, choose 6, times by 0.8 to the power of 6 times by 0.2 to the power of 2. Okay, same thing here, probability that x is equal to 7. You're going to have 8, choose 7, times by 0.8 to the 7 times by 0.2 to the power of 1. Okay, probability that x is equal to 8, so all 8 of them germinate. 8, choose 8, times by 0.8 to the power of 8 times by 0.2 to the power of 0. Okay, now let's just chuck that into a calculator, so I'm just going to do that here. I'll just use this one here, probably the easiest one to do. So I'll work at that first one, so option here, probability 8, choose 6. If you want to go straight to the answer, just skip past this bit here, that's fine. This is literally how long it would take anyway in an exam, so this one here gives you, so for this one here, probability that x is equal to 6 gives you about 0.293 roughly. You can check my working as well with your own calculator. I do get some of these wrong sometimes, but it's very rarely. But if I do make any mistake, also comment it as well. And then we'll do here. And this one is probability x is equal to 7 is 0.33, and then 8 and this one's incredibly small. So probability that x is equal to 8, I'm just going to write in scientific notation, is 4.29 times 10 to the negative 7. So that's ridiculously small. That's 7 zeros in front of it. So realistically, just add these two together and it'll give you your about answer. Now, judging from it, if I were to zoom out, let's just add them together. If we go here, 0.293 plus 0.33, 0.62. With a seed variety that doesn't match any of those answers here. I'm just going to double check my working, so give me 1 second. At least 6 seeds will germinate. X has to be greater or equal to 6. At least 6, so 6 or more. Well, we have to include the 6 because it's at least 6. That one is that it's 6, 7. Make sure I did that one properly. Sorry guys, just skip past this as well. Unfortunately, I can only do it really in one take. I might make a part 2 actually. Hold up, I'll just probably end the video there. I'll just record a part 2, okay? I'll see you guys in the next part, alright?